Hi, my name is Marco Panizza, and I'm working at Panasonic in the technical marketing and new business development area, responsible for power electronic products and solutions. One of the highlights that we have in this year at PCIM are our GaN power semiconductors. And beside the general use that we have of the GaN and the availability of the GaN, we want to talk today of a specific application of GaN where many advantages can be seen by using GaN instead of other conventional silicon structures. Typically, we talk about motion control and motor driving. In an automation system or in a robotic system, nowadays there are many motors actuating many parts of the machines. And typically, each motor needs a dedicated servo amplifier or a motor drive in order to control the motion of the motor very accurately. So you have a solution like this where you have many channels of an AC servo amplifier and motors spread across. In this case, the robotic arms. It could be an automated machine for a production line. The issue is that each motor, which is an induction motor, is a synchronous motor, needs 3 cables at least for the driving. And of course, the cabling of the motor becomes complex when you have a constrained space. Like you see here, you have a lot of cables running around in order to activate each motor. The advantage of using GaN, because of the high efficiency that can be achieved and the miniaturization that can be achieved, allows to reduce the size of the motor driver. And that's exactly the application that I'd like to show you. A motor driver can be implemented in a single board like this, and you recognize here 6 devices, which are the 6 GaN to implement the 3-phase bridge. Now the beauty of these is that these can be inserted into a motor structure like this, and you have a fully integrated system where the motor and the motor driver is included in a single case. So when you have this solution, you can mount it inside the robots or inside an automated machine, and you don't need to run all the cabling because the connection is already made inside the motor itself. So you can appreciate here how the system is much simplified. There is much less cables. It's lightweight. There is less electromagnetic disturbances because you don't carry around high frequency signals on the cables. It's much simplified, and in this case, the inverter is just mounted into the robotic arms. It could be on the motor structure. It could be placed in a convenient point where the whole system can be simplified. And this is achieved just because the heat dissipation generated by the GaN is much reduced compared to a silicon solution. So the dimension can be reduced and everything can be integrated in a single space. So eventually the machine will get rid of the separated servo amplifier. You just need an AC to DC source, which is typically 380 or 400 volt. You propagate the voltage across the system, across the machine, and you just have motors with an intelligence and a driving already built in based on GaN converters. So we think this is an advancement in this type of architecture. Automated machines are becoming more and more important, mostly in view of the Industry 4.0 concept. And therefore, this approach will simplify and will improve the performances of this type of designs. So thank you very much for listening. I hope it's been useful for you, and we gave you some good hints.